I think these were some of the basic questions that are part of our syllabus. Basic questions which are part of our syllabus.
By the at the back of your house, because I don't think tomorrow we'll be able to come back again. What time are you leaving tomorrow? And yeah, tomorrow I'll be also for. Oh, am I? Oh my goodness.
You are saying?
Sorry, I actually forgot that I didn't mute my my speaker. Sorry.
Oh, it's not. Okay. It's okay. I thought it's part of us here. All right. No problem. No problem. It's okay. So we're given the first part, giving your answer as a decimal, find the exact value of given these two fractions. We are just applying our normal addition, and so this one is just your normal addition that you're supposed to apply. What was the idea in this case? 1/5 plus 2/7. What were you supposed to obtain? What were you supposed to have at the end? The LCM of 5 and 7 was going to be what?
35.
35 in this case. So we are going to apply 35. Then we divide back 35 divided to 5. We are going to be, it's going to be what? 7. And then this 7 times 1, which is going to be 7, plus 35 divided to this 7 is going to be 5. Then multiply to 2 is going to be what? 10. Is that so? So we are going to add now 7 plus 10, which was going to be 17 over what? Over 35. Then also check if there is a common factor. Sometimes we might have a common factor. Always try to check for that. If there is a common term between 17 and 35, do we have a common term? We do have a common term, or we do not? Do we have a common term between these? We do not. Done. So that is that means in this case we are done. What if I was just to make the denominators to be the same? We can just play around this condition. Remember that if you are given maybe we've got 5/7 plus 1/7. If the denominators are the same, we can simply combine what? Our numerators together. We can simply add 5 plus 1, which is going to be 6 over what? 6/7. Is that so? So meaning to say, we can also opt for that to make the these denominators to be the same, 5 and 7. How can we make these to be the same? We just interchange what we have here. We've got a 5. We do not have this 7. So we are simply going to multiply by 7/7. So it's going to be 7/7. Multiplying by 7/7, you're simply multiplying by 1. The same part here, in order for us to have 5 this side, we are going to multiply by 5/5. So the moment you interchange these denominators here, we are going to have the same denominator now, because here we are going to multiply 7 by what? By 1, which is 7/7 times 5, which is 35, plus 2 times 5, which is a 10, over 7 times 5, which is 35. Once you are having these denominators being the same, like you can simply what? Add the numerators, like the given condition that we explained, that I was explaining here. So it's going to be 7 plus 10, which is what? 17 over 35. So it can be another way, and we are just supposed to be careful also on our simplification. Okay, I don't know if there is a question. Any question on this part?
No.
All right, no problem. So yes, is there a question? All right, so it's fine. Then the other part here, if we're to simplify, I just want to check because yes, direct, you're supposed to apply. Of simply means you are multiplying this 7 over 9 of this, but we've got brackets in this case. So you're supposed to simplify what is inside the brackets in this case. So I don't know if we all obtained the same answer, which is supposed to be something like 7 over 36. Are we all having 7 over 36?
Yes.
All right. Is there anyone who is having a different answer? A different answer is fine. Okay. What about, so meaning to say let us just, yes, any? Oh. What about 13 over 40?
Excuse me.
Yes. 13
I
over
got
40.
0, I got 325.
325. All right. Are we having different answers there? Anyone with a different answer?
I'm having the same answer as for number 1B.
Yes, you are saying? Oh, so that is what we all had. All right. So some of these questions, they are direct, and that's why I'm asking so that we can revise if your answer is not the same, because I think this part was a little bit direct. But this one now, what was the idea on this part? We are supposed to express this in standard form. So someone will be saying this number is in standard form. Is this number in standard form?
No.
Why?
4,000
This number.
Not in standard form.
Exactly. This part here, this part, we are supposed to consider this part. It's not between 1 and 10. Yes, our format there is supposed to be a times 10 to the exponent of n. So it's not just using 10 to the exponent of a certain power. No. This number a is supposed to be within the numbers, or in between, supposed to be in between these numbers from 1 to a number that is less than 9. We are actually saying our a supposed to be within that interval. So we are supposed to work with what? This number. Let's convert this number first to standard form. So what are we going to have at the end? From this number here, we are going to move the comma from this point. That will be 1, 2, 3. So meaning to say we are at this point. So we are going to have what? 4,85. So this 0 here is not important, and times 10 to the exponent of what? How many commas are we considering? 1, 2, 3. So it's to the exponent or to the power of 3. But already we are considering this part here. We are having what? 10 to the power of -1. On the original part of our question, there was 10 to the power of -1. So we're going to consider 10 to the power of -1 in this case like this. All right. Meaning to say at the end, we are supposed to combine these two. Because here we are not talking about what? Same basis, and back to your indices there, considering multiplying the same basis, what is going to happen? If we are multiplying the same basis, we are going to add the exponents to power. So 3 plus -1 is going to be what? Is going to be a 2. And so meaning to say on this one, we are going to obtain a 2. I don't know if we are together. So that was the idea of this part here. Okay, I don't know. Someone can convert first, because 10 to the power -1 means what? 4,850 like this times 10 to the power -1. What does it mean? we are simply dividing by 1/10, or we are simply moving 1 comma to the left if we are to convert to ordinary form. So the comma is here, we are going to move 1 comma back to the left. So meaning to say this number as it is, we are going to obtain 485, comma 0 in this case, of which comma 0 is not going to affect this part of our question. So we are going to have what? 485. From this part alone, we're going to have 485. Then you can convert now 485 to standard form, right? As a number between your comma is now on this part. So we're going to move moment commas 1, 2 in this case. So meaning to say we are going to obtain 4,85 times 10 to the power of what? Times 10 to the power of 2. Still we are obtaining the same answer. We are obtaining the same answer in that case. So there are so many ways. I don't know if there is a question from this part. Hello, any question? All right, no. Yes, is that a question?
Maybe if someone is not talking, maybe if someone is not talking, they can their mics.
Oh, all right.
So if it's 08 such a it's always that supposed to be one number before the
all right, no problem. So what you can do, if you have a question, you can switch on your mic, or if you want to respond something so that it can not affect others. All right. So this other part we're given, John works 46.5 hours per week and is paid 5,000 per hour. So find John's weekly wage. So I think this one is a direct question also from your proportion. We have the number of hours in this case considered per week. And this amount is given as per hour. Each and every hour that is going to work is given what? 5,000 in this case. So meaning to say what you simply need is to know already you are given the total number of hours per that week. If we are given like a condition, the hours that is working in a day, then you now you are supposed to calculate the total number of hours that is going to work in a week. But here we are already given the number of hours per week in that week.
Right.
Are we seeing that? We are already given direct. So we are going to simply multiply the number of hours that, or it's just a proportion, or you can use proportion, but here we are already having like 1 hour, it's 5,000. What about these hours? They correspond to what? You are going to simply multiply. So we have got 46.5 in this case, which is supposed to multiply the total amount that we are given per hour in this case, the amount per hour times the number of hours worked. But in order for us to multiply properly, what can we do? We can have it as a decimal, or we can consider it as an improper fraction. That part of multiplication, the multiplication part is a choice. So you can consider as a decimal, 46,5 or 46.5 times what? Times 5,000. You can multiply, obtain your answer. Or you can consider as an improper fraction, 46.5, you multiply by 2, you add 1. So if you multiply by 2 here, what are you going to have? 46 times 2, you get what? 92. That's all. Then 92 plus 1, which is 93. So you're going to obtain 93 over 2 times what? Times 5,000. Here now they're just testing your multiplication part. They know that most of us, we are used to using calculators and so forth. So meaning to say the multiplication now, it's, yeah, so I don't know what was the final answer at the end after multiplying this part, or after multiplying this part, what was our final answer? Hello. What was support? What was off? You got what?
I got 230,000. Yes, 230,000 I got. $230,000. I made a mistake. I multiplied by 92 instead of 93.
It's what? 90?
I made a mistake. I multiplied by 92 instead of 93. By 92 instead of 93.
Or on the conversion part here?
Yes,
Is
yeah.
it? Oh, all right. So here you multiply these two. You multiply these two, then you add a 1. So it's 2 times this, 46, which is 92. Then 92, you add 1 now. So it will be 93 over 2. Are we together on that part? So meaning to say it was going to affect our final answer, because we are supposed to obtain now something like 232, something like this, 232,000. I don't know if it's what we are all obtaining. Is it what you guys obtained?
Yes, sir, we obtained that one.
Okay, so that is the whole idea of our question here. So it's just a normal part, or you can use it as an hour, and 1 hour is equal to this. What about this? Is going to be more, so more over 1 times the amount, still it's one and the same thing. Then what are they trying to ask here on question 3, whereby we are given to find the temperature after the rise in this case. The temperature inside a freezer is -8. This is our initial temperature. During a power cut, the temperature rose by what? By 12 degrees Celsius. It rose, meaning to say there's an increase in this case. Find the temperature after the rise. So what was supposed, let's say the temperature was at 2 degrees Celsius, because we just used to normal whole numbers, like positive whole numbers. If our temperature was at 2, then it rose by 12. What was going to happen? If the temperature increases by 12, we are simply going to add on. So it is the same idea. Even if it is a negative here, the temperature initially, it was at what? -8. Then it increased now by what? By 12. So to increase, we are supposed to add 12 degrees. So there they are just testing you directed numbers. That is the consideration there, the directed numbers concept. So in this case, the signs are different. So you can simply subtract 12 minus what? -8, which is 4. Then you take the sign of the bigger number, which is what? Which is a positive. So it is going to be at 4 degrees Celsius after it is increased by what? By 12. We are simply adding. I don't know if we are together on this part. Right, so that is it there. On the B part, the sequence there, the number of terms, sequence, and application of a series and so forth. Write down the next 2 terms in the following sequence. So we are given a sequence. So if you are dealing with a sequence, you study what is happening there. You study the layout of numbers. How are they given? As you can see, it's just 1 mark for each answer that you get. So you just have to study. We do not have special formulas that you can work with. So what was the idea there? What do you think was happening from 1 to a half, from a half to 1/4 to 1/8? If we check here, we are simply dividing by a half, or we this one you consider the way that you understand. Like this one, you can consider it as 1/1. All right, 1/2, 1/4, 1/8. What is happening here from 1 to 2? Because the one on top is not changing. The one on top is not changing. What is happening here from 1 to 2, from 2 to 4, from 4 to 8? What is happening? We are simply multiplying by what? By 2. That is the whole idea of our question. We are simply multiplying by 2 in this case to say this one times 2, we get this. This one times 2, we get this part. This one times 2, we get this. So meaning to say the next term is going to be times 2 again. 8 times 2 is going to be what? 16. So meaning to say we are going, the one on top is not changing, so it's going to be 1 over 8 times 2, which is now at what? At 16. That's the next term. We move on to the other part, 1 over what? The next term again, we are simply multiplying by 2. Whatever that's going to happen here times 2, 16 times 2, which is going to be what? That would be 32. So we are going to have the 2 terms. Take note, they are asking for 2 terms. They can ask for 3. They can ask for the next term. If they are saying the next term, you just answer the next term only. So here our answer is supposed to be this one and this one. So like I said, even if you have to consider this way, you can see that here it was actually a division that is happening. We are dividing by 2. If you are dividing a fraction, because most of us were confused to say, how are we going to divide 1 over 2 to get 1 over 4? If you are considering a fraction in this case, if you have got A over B as a single fraction, this one is a single term, that's our fraction, being divided to a single number. We are considering A over B divided. You simply multiply the denominators together on this condition. Denominators together, so this one, it gives us A over BC. If I am given 1 over 200 like this, divided to 3, it simply means I'm just going to multiply these 2. So it's going to be 1 over 200 times 3, which is going to be 600. So meaning to say, just using this quick approach that we are talking about here, if I divide by 2 here, 1 over 2 divided by 2, it means 2 times 2, which is a 4. 1 over 4 divided by 2, it means 1 over 4. 4 times 2, which is going to be 8. We are simply applying the same technique here, times 2, times 2, times 2 in the denominators. But the actual approach was supposed to be like this. We are dividing by this denominator. But if you are having a denominator versus another denominator from a single fraction, you multiply the 2. I don't know if this concept is clear. All right, so this is a revision. That's why we are talking about some other approaches, because we can have it as fractions. Now it's given as x plus 2 over a certain fraction of x plus 3, like this. Maybe you are calculating, or then there's just a single number, which is 3. Then you are now starting to say, okay, I'm dividing here. I'm not saying it's wrong. You are now writing x plus 2 over x plus 3 divided to, because that is what it means here to say this fraction is being divided. We are dividing by what? We are dividing by 3. That is the exact layout that we are seeing, meaning to say we are dividing by 3, which is same as 3 over 1. We now introduce multiplication, x plus 2 over x plus 3 times 1 over 3. So you see the procedure, the process there, we have a lot of things that we are now considering, which is fine. I'm not saying it's wrong. It's actually, but if you can understand that concept that I was explaining, you can see, okay, here I've got a fraction, a single fraction on top, and a single term here. So I'm just going to combine my what? My denominators here. So meaning to say at the end, this whole part is going to give us x plus 2, everything over 3 times this part in the denominator. So it's 3 into x plus what? Into x plus 3, which is the same answer that you're going to obtain here, because you're going to multiply the numerators together now, the denominators together. You're going to obtain the same answer as this one. So it saves us time by knowing some other techniques, but if you are using the original way, or it's still one and the same thing. I don't know if we are together. I do not want us to have confusion, especially on the last days like this. We can stick to whatever part that you understand. Then write 3,35 minutes in minutes and seconds. Yeah, these are very, very typical questions like this. It's in minutes. They want us to have our answer in minutes and seconds. You also wonder to see a question of the same nature. Maybe you're asked to write 2,45 hours like this. Then this one, they will ask you to give your answer in hours and minutes. This one, they're asking us to give our answer in minutes and seconds. All right, what is the consideration? What is the consideration there? What is the consideration that we are supposed to apply?
I said 35 over 60. Oh, 35 over 100 times 60. Is it correct to say 3 minutes plus 35 over 100 times 60? And then 35 over 100 times 60 will end up reducing to 21 seconds. Is it correct?
All right, sorry, I just wanted to pick a certain call. All right, I was asking here, we have got two typical questions that we are going to be having on our exams. Like you are given a question that is in minutes, then they're asking you're supposed to have your answer in minutes and what? Seconds. If you are given the same approach of a question in hours, if it is in hours like this, you are going to see that they are going to ask this question as expressed in hours and minutes. What is the whole idea of this question? What is the whole idea? What is the whole idea of our question? All right. The whole number that we are seeing in this case, this whole expression is in minutes. So meaning to say, we have got the number, the full number here, which is the 3, representing the a whole number of minutes, like complete minutes that are being taken. To say we have got 3 minutes, 3 whole minutes, the full minutes that are being taken, which is 3. Satrat ma minutes akazara ataka complete mangani. We are talking about 3 minutes, which were being what? Completed there. But there is a remainder that is so we're having 3 minutes in this case. And a remainder, the comma here that we're seeing, the comma 0,35. If we remove 3 minutes here, we are going to remain with the 0,35 minutes again. These are also because we are under minutes. So we have got the minutes and we have another part also in minutes. This part is in minutes and also this part is in minutes. So the question now, when they are asking to convert or to write in minutes and seconds, you are going to represent the minutes by the whole number. This is representing what? The whole number, the full minutes which were being completed. This one, the decimal part, it's as you can see, it's less than a minute. 0, we are talking about a fraction. This one, it's a fraction of a minute. So we are now converting this fraction of a minute, the decimal here, the 0,35. Remember, this is same as 35 over 100. We've got 2 decimal places. It's same as 35 over 100. So it's a fraction of a minute. It's not a complete minute. So the fraction part or the remainder part is the one that you're going to convert now to what? To seconds. So that we obtain a whole number, we obtain the full seconds which were being taken. It's like, let us just say we've covered 30 seconds. How many minutes have we covered? If we have covered 30 seconds, how many minutes have we covered?
0,30.
0,30. 0.30, 0.30, 0, it's supposed to be 0.3. 5, a half, it's a half. 30 seconds, it's a half of a minute, and a minute, it's 60 seconds. So 30 seconds, it's a half of a minute that we are talking about. It's a half of a minute, meaning to say we are talking about 0.5 minutes in this case. It's a fraction of a minute. It's not a complete, we are not having a complete cycle, but when you express this to seconds, you say this is a complete cycle in terms of seconds. We have completed 30 seconds. So that is the whole idea here. This 0.35, it's a remainder that we are taking from the whole number here. You remain with the 0.35. So that remainder is the one that you convert now to seconds. So how are you going to convert to seconds? You simply multiply by what? By 60. Remember that in a minute, we've got 60 seconds. So you're going to multiply by 60 seconds now, which means you can multiply the decimal or you can multiply the fraction, whatever that you're going to use. Is it the decimal or the fraction? You're supposed to obtain the same answer. All right, so what are you going to have at the end? That's a placeholder here. So you're going to multiply 6 times 5, which is a 30. 6 times this 3, which is 18. 18 plus 3, which is going to be what? Which is going to be 21. Then how many decimal places are we having here? 1, 2. So we're going to have 1, 2. So meaning to say we are going to have 21,00. These are the full seconds that we have. Remember, 0.00, we do not consider these. So these are the seconds. Remember, here we multiply by 60 to convert to seconds, 60 seconds. So meaning at the end, our answer is going to be what? 3 minutes, which is the whole part that we had. So we've got 3 minutes. How many seconds? 21 seconds. So we've got 3 minutes and 21 seconds, which is the same with the same part that we had, the same minutes that we had, but now we just expressed these minutes as minutes and what? Minutes and seconds. So if you were given in hours like this, 2.45, what is it? What does it mean here? What does it mean? It means we have got 2 hours that are complete. The complete number of hours that we have here is 2. So we are going to have 2 hours complete. But there is a remaining, the moment we remove this complete part that we are having, the complete number of hours, we are remaining with what? The 0.45, this one. So we are going to remain with the 0.45, which are not minutes. No, they are not minutes, they are hours. As it is 0.45, it's in hours. But it's less than an hour, this one. It's a fraction of an hour. So how many minutes do we have in this fraction of an hour? So this is the one now that you're converting to minutes. So please take note, you are given here minutes, you shall express in minutes and seconds. You are given hours, your answer shall be hours and what? And minutes. So meaning to say we are back again. How do you convert hours to minutes? In an hour, we've got what? 60 minutes. So we are going to simply multiply by 60. 0.45 times what? Times 60. So I think we are together. So if you multiply properly, just for the sake of time, 0.45 is going to give us what? 0.45 times 60 is supposed to give us something like 27. 27,00. So these are now the minutes that we have obtained from what? From the fraction of an hour. So at the end, we are saying from this whole part that we've got 2 hours that are complete. And how many minutes? 27 minutes. So it's the same approach, whether you are given hours here or you are given minutes. So it means it can also affect even a distance. It's not about time, it can even affect distance. 3.5 kilometers can be expressed in kilometers and what? Kilometers and hours. This can be written in kilometers and hours in this case. So what are we trying to say if it can return in kilometers and hours? We are saying now to kilometers and hours, kilometers and meters, they can want to know us like how many kilometers that we have and the meters. So the 3 is representing the full kilometers. The remaining is the one that is in what? That is in meters. So that is the whole approach of these typical questions, whereby you are being asked to write in kilometers and meters, or it's a time whereby you're dealing with hours and minutes, or time in minutes and seconds. I don't know if it is clear. Are we clear on this part?
Yes.
All right, so let's see. Let's see. All right, so the other part